In this video lecture, I'm going to teach you how to complete compound stoichiometry problems. So some things to remember before we get into the problems. We are going to be following the dimensional analysis process, which uses conversion factors to convert a given value and unit into a different unit. And so the conversion factors that we are going to use include the molar mass, which we have practiced calculating. It is the amount of grams in 1 mole of that substance, and we use the periodic table in addition to the formula of the compound to calculate that. If you need to review this concept, make sure you do that prior to moving on with this video. The second conversion factor we are going to use is called Avogadro's number. That is a constant. It is 6.022 times 10 to the 23rd particles per mole. Now, particles can either refer to the amount of atoms per mole if you are just looking at a single element like sodium, or it can mean molecules per mole if we are looking at a substance such as sodium chloride, which is 2 elements bonded together. So depending on what substance you're looking at, we would replace the word particles with either atoms or molecules, but the number stays the same no matter what, and it's that many particles per 1 mole, no matter the substance. Some other things to remember: the dimensional analysis process, you want to put the same units diagonal from each other in order to cancel them out and thus convert to a new unit. We use conversion factors, like I just mentioned, to convert the units. And when you are done, when all the units cancel out except for the specific unit you are looking for, you multiply the numbers across the top and then divide across the bottom to get your answer. One other thing that I would like to mention: make sure that you are including units on every single number that you write. It might not seem as important right now, but it is going to be extremely important when we get into reaction stoichiometry problems later. So the first type of problem we're going to look at is converting moles of a substance to grams. So when we're going moles to grams, we're going to start with the amount of moles of a substance that will be given to us in the problem, and we want to convert to grams of that substance, obviously. To do this, the conversion factor we are going to use is the molar mass of that substance, which again is how many grams are in 1 mole, which we have practiced calculating in class. So let's do some practice problems. That's the easiest way to learn this. So the question is saying how many grams of neon are in 5.75 moles. Now the molar mass of neon, if you look on the periodic table, we can round to 20 grams per mole. We're going to use that. So with the dimensional analysis process, you take the number given to you in the problem and you put it in the upper left-hand box. So I put the 5.75 moles of neon in the upper left-hand box. Now, moles can be abbreviated MOL. You don't have to write out the whole word every time. And you also want to practice putting the given substance after the unit for each number. So instead of just putting 5.75 moles, put 5.75 moles of neon. And again, it might not seem very important right now, but it will be when we get into reaction stoich problems. Now, since I have moles of neon up, I need to put moles of neon diagonal down. And the conversion factor we are using to convert moles to grams is 20 grams per mole. So I'm going to put 1 mole of neon diagonal down so that the moles of neon cancel out, and I will put the 20 grams on top. So this molar mass that I found on the periodic table can be written as a conversion factor that looks like this. Since the moles cancel out, I am left with grams of neon, which is what the problem is asking me for. So I just plug this into my calculator. 5.75 times 20 divided by 1 would get me an answer of 115 grams of neon. Let's try another problem. How many grams of sodium chloride are in 1.95 moles? To start, let's first turn the name into a formula and calculate the molar mass. So I know sodium chloride is NaCl. We have 1 sodium at a molar mass of 23 grams per mole, plus 1 chlorine at 35.4. You add those together to get a total of 58.4 grams per mole. Now I'm going to start by putting the number given to us in the problem in the upper left-hand box. So the 1.95 moles will go up here. I'm also including the formula for the given compound as a good practice. Again, might not seem important now, but it will be very important later. And then since I have moles of NaCl up, I want to put moles of NaCl down. This is the conversion factor we are going to be using. So I know there's 58.4 grams in 1 mole of sodium chloride, so I can put the 1 mole diagonal down and the 58.4 grams up. The moles of NaCl cancel out, leaving me with grams, which is what I wanted. So I can multiply across the top, divide across the bottom. 1.95 times 58.4 divided by 1 would get me an answer of 113.88 grams of NaCl. Let's try one last problem here. How many grams of lithium nitrite are in 2.11 moles? So first we need to turn this name into a formula and then calculate its molar mass. So lithium nitrate I know is LiNO2. Lithium's a +1, nitrite's a -1. So when I crisscross, they cancel out. I have 1 lithium at 7 grams per mole. I'm getting these numbers off the periodic table, remember. Plus 1 nitrogen at 14 grams per mole, and 2 oxygens at 16 grams per mole each. When I add all that up, I get a molar mass of 53 grams per mole. So I'm going to start the actual process to solving the problem by putting the number given to me in the problem in the upper left-hand box. So 2.11 moles of lithium nitrite go in the upper left. Since I have moles of lithium nitrite up, I'm going to put moles of lithium nitrite down. The conversion factor I'm using says there's 53 grams in 1 mole. So I'm going to put 1 mole of lithium nitrite down, and then the 53 grams up. My moles of lithium nitrite cancel out, leaving me with grams of lithium nitrite, and that is exactly what I want. So I can multiply across the top and divide by the bottom. So 2.11 times 53 divided by 1 will give me 111.83 grams of lithium nitrite. I would like you to please pause the video and take some time to practice these specific types of problems on page 1 of your Compound Stoich practice packet. There are 10 questions. They have you do this exact same calculation, and there is an answer key at the bottom. Once you feel comfortable with this type of problem, come back and start the video for the next section. The next section is going grams to moles. For these types of problems, you are given, and we will start with the grams of a substance and convert it into moles of that substance, again, using the conversion factor of the molar mass of that substance in grams per mole. But this time, we are going to have to flip it upside down. So let's do a problem because it's the best way to learn these. The question asks how many moles are in 122.50 grams of calcium. I'm going to need the molar mass in order to convert. So I looked on the periodic table, and the molar mass of calcium is 40 grams per mole. I'm going to start the problem by plugging the number from the actual question into the upper left-hand box. So 122.50 grams of calcium goes there. Now, since I have grams of calcium up, I need to put grams of calcium diagonal down so that it will cancel out. If I'm using this conversion factor, there's 40 grams in 1 mole of calcium, I can plug the 40 grams of calcium into the bottom box and the 1 mole on top. So I took that conversion factor we used in the last type of problem, and this time I flipped it. Grams on the bottom, moles on the top, so that the grams of calcium cancel out, and I'm left with moles. So now I can multiply across the top, divide by the bottom. 122.50 times 1 divided by 40 would get me an answer of 3.063 moles of calcium. If we look at another problem, how many moles are in 85.9 grams of sodium fluoride? Start by writing out the formula and calculating the molar mass. Sodium with a +1 and fluorine with a -1 are going to create the formula NaF. 1 sodium at 23 grams per mole plus 1 fluorine at 19 grams per mole would equal 42 grams per mole for sodium fluoride. Again, these numbers come from the periodic table. I'm going to start by putting the number given to us in the problem in the upper left-hand box. So 85.9 grams of sodium fluoride goes there. Since I have grams of NaF up, I need to put grams of NaF down. In my conversion factor, I know there's 42 grams in 1 mole of NaF. So the 42 grams will go on the bottom so that grams will cancel out, and the 1 mole will go on top. Now that my grams cancel out, I'm left with moles of sodium fluoride, which is what I wanted. So I can multiply across the top and divide by the bottom. 85.9 times 1 divided by 42 would get me an answer of 2.05 moles of NaF. Let's try one more problem. How many moles are in 234.11 grams of zinc hydroxide? I'm going to start by writing the formula and calculating the molar mass. Zinc has an oxidation number of +2. Hydroxide, which is OH, has a charge of -1. When you crisscross, you get ZnOH2 with the 2 outside of the parentheses so that it applies to both the O and the H. I'm going to find the molar mass. 1 zinc at 65.4 grams per mole, plus we have 2 oxygens at 16 grams per mole each, plus 2 hydrogens at 1 gram per mole each, gets you a grand total of 99.4 grams per mole. I'm going to start by putting the number given to us in the problem in the upper left-hand box, so 234.11 grams of zinc hydroxide. Since I have grams of zinc hydroxide up, I need to do grams of zinc hydroxide down. My conversion factor says that there's 99.4 grams in 1 mole of zinc hydroxide. So that means I'm going to put the 99.4 grams down and the 1 mole on top. My grams of zinc hydroxide will cancel out, leaving me with moles of zinc hydroxide, which is what I want. So I can multiply across the top and divide by the bottom. 234.11 times 1 divided by 99.4 gets me a total of 2.4 moles of zinc hydroxide. Please take some time, pause the video, and try these types of calculation using page 2 of your Compound Stoich Practice Packet. There are 10 problems on that page with an answer key, and they are all going to follow the same exact type of calculation. When you feel comfortable with that type of a problem, please come back and start the video for the next section. The next type of problem is moles to particles. So we are going to start with moles of a substance and convert it to either atoms or molecules of that substance, depending on the substance. For a conversion factor, we are going to use Avogadro's number, which is 6.022 times 10 to the 23rd particles per mole. So let's try a problem. How many atoms are in 3.72 moles of potassium? We do not need to use the molar mass for these problems because they do not consist or involve grams in any way. So all we do is we plug the number given to us in the problem in the upper left-hand box. So 3.72 moles of potassium goes in the upper left. And remember, please practice putting both a unit and the formula or symbol for the substance after each number. It might not seem important now, but it will when we get to reaction stoich. So since I have moles of potassium up, I'm going to need to do moles of potassium down. Remember that my conversion factor is Avogadro's number. There's 6.022 times 10 to the 23rd particles per 1 mole of a substance. So I'm going to put the 1 mole diagonal down so that moles cancel out. And then I'm going to put 6.022 times 10 to the 23rd atoms of potassium up. Now, since I'm just looking at a single element, I am going to change the word particles that was given in the unit of Avogadro's number to atoms to specify that I am looking at atoms of potassium instead of molecules. Now that I have it in atoms of potassium, which is what I wanted, I can multiply across the top and divide by the bottom. 3.72 times 6.022 times 10 to the 23rd divided by 1 gets you an answer of 2.24 times 10 to the 24th atoms of potassium. Now, the hardest part of these problems is plugging it into a calculator. Whenever you're dealing with numbers that have times 10 to an exponent, you have to know your calculator and know how to plug it in correctly so that you get the correct answer. More often than not, if someone gives me an incorrect answer, it is because they are not using their calculator correctly. So please, as we go through these problems, try and plug each one into your calculator so that you can figure out how to plug these into your calculator correctly to get the right answer. I'd hate for you to get something wrong just because you can't plug it into your calculator correctly. The next problem says, how many molecules are in 7.71 moles of strontium sulfide? Again, we do not need to calculate the molar mass of this compound because grams is not anywhere in this calculation. So we can just use Avogadro's number again. We're going to take the number from the problem and plug it into the upper left-hand box. So we put 7.71 moles of strontium sulfide, which the formula for that is SRS. Strontium is a +2, sulfide is sulfur with a -2. Equal and opposite, so they cancel out. Since I have moles of strontium sulfide up, I need to do moles of strontium sulfide diagonal down. Again, I'm using Avogadro's number, so I know that that's going to be 1 mole of strontium sulfide is equal to 6.022 times 10 to the 23rd molecules of strontium sulfide. Now notice here how after Avogadro's number, I put molecules of SRS. I switched it from atoms to molecules because now I'm working with a compound. Putting atoms is not a correct unit when we are working with a compound. So just be careful with that. Now that my moles of strontium sulfide cancel out and I am left with molecules of strontium sulfide, I can multiply across the top and divide by the bottom. So 7.71 times 6.022 times 10 to the 23rd divided by 1 will get you an answer of 4.64 times 10 to the 24th molecules of strontium sulfide. Again, please practice calculating this just to make sure that you are plugging it into your calculator correctly and getting the correct answer. Again, chances are if you get one of these wrong, it's due to you not plugging it into your calculator correctly, most likely. One more problem here. How many molecules are in 2.93 moles of iron 2 nitrate? Iron 2 nitrate, that iron is Fe with a +2 oxidation number. Nitrate is NO3 with a -1. So that gets me a formula of FeNO32. I'm going to start by putting the number given to me in the problem in the upper left-hand box. So that gives me 2.93 moles of iron nitrate there. Since I have moles up, I need to do moles diagonal. And I'm again using Avogadro's number. So I'm going to put 1 mole of iron 2 nitrate down and 6.022 times 10 to the 23rd molecules of iron nitrate up. My moles cancel out, leaving me with molecules of iron 2 nitrate, which is what I'm looking for. So I can multiply across the top and divide by the bottom. 2.93 times 6.022 times 10 to the 23rd divided by 1 would get you an answer of 1.76 times 10 to the 24th molecules of iron 2 nitrate. Again, please plug this into your calculator and make sure that you get the same answer. If you don't, you probably are plugging it into your calculator incorrectly. So why don't you pause the video, take some time to practice these types of problems, and especially practice plugging them into your calculator. These types of problems are located on page 3 of your Compound Stoich Practice Packet. Do as many or as few problems as you need to. There's an answer key attached to those problems. And then when you're ready, start the video back up to go on to the next section. The next section is going from particles to moles, which is the last calculation, but backwards. So now we're going to start with either atoms or molecules of a substance and convert it into moles of that substance. We are going to again use Avogadro's number, which is 6.022 times 10 to the 23rd particles per mole as a conversion factor, but this time we are going to flip it so that it's upside down as compared to how we used it in the last part. So let's try a problem. How many moles are 9.05 times 10 to the 25th atoms of carbon? I'm going to start by putting that number in my upper left-hand box, again following it with a unit and the symbol for carbon. So there's my 9.05 times 10 to the 25th. Since I have atoms of carbon up, I need to do atoms of carbon diagonal down to cancel it out. My conversion factor for these, right, going atoms to moles, is Avogadro's number. So I'm going to put the 6.022 times 10 to the 23rd atoms of carbon diagonal down and 1 mole of carbon up. My atoms of carbon will cancel out, leaving me with moles of carbon, which is what I want. So I can multiply across the top and divide by the bottom. So that would be 9.05 times 10 to the 25th times 1 divided by 6.022 times 10 to the 23rd. That should come out to 150.28 moles of carbon. The last type of problem took some getting used to when you plugged it into your calculator. These are going to also play that same game. So please try to plug these into your calculator and make sure that you are getting the same answer. If you are not plugging this into your calculator correctly. The next one says how many moles are in 1.22 times 10 to the 24th molecules of carbon tetrabromide? Remember, carbon tetrabromide, that tetra is telling us that it's a covalent compound. The lack of a prefix on the carbon tells me there's one carbon. Tetra on the bromide tells me there's 4 bromines. So I'm going to start by plugging that number given to me in the problem into the upper left-hand box. 1.22 times 10 to the 24th molecules of carbon tetrabromide, and it's molecules because we are working with a compound. Since I have molecules of carbon tetrabromide up, I need to do molecules of carbon tetrabromide down, and again, our conversion factor when going molecules to moles is Avogadro's number. So I'm going to put 6.022 times 10 to the 24th molecules diagonal down, and 1 mole of carbon tetrabromide up. The molecules cancel out, leaving me with moles of carbon tetrabromide, which is what I want. So I can multiply across the top and divide by the bottom. So that would be 1.22 times 10 to the 24th times 1 divided by 6.022 times 10 to the 23rd. And when you plug that in correctly, you should get an answer of 2.03 moles of carbon tetrabromide. Again, please plug this into your calculator and make sure that you get the same answer. If you don't, you plugged it into your calculator incorrectly. One more problem. How many moles are in 5.55 times 10 to the 23rd molecules of copper 2 sulfite? Copper 2 means that is Cu with a +2 oxidation number. Sulfite is SO3 with a -2. Those are equal and opposite, so they cancel out, leaving us with CuSO3. I'm going to start by putting the number given to us in the problem in the upper left-hand box, making sure to follow it with a unit and the formula. Again, doesn't seem important now, will be important when we get to reaction stoich. So I put the 5.55 times 10 to the 23rd molecules of CuSO3 up. Since I have molecules up, I need to put molecules down. Again, our conversion factor when going molecules to moles is Avogadro's number. So I put the 6.022 times 10 to the 23rd molecules of copper 2 sulfite down, 1 mole up. My molecules cancel out and I'm left with moles, so I can multiply across the top and divide by the bottom. 5.55 times 10 to the 23rd times 1 divided by 6.022 times 10 to the 23rd should get you an answer of 0.92 moles of copper 2 sulfite. Again, please plug this into your calculator and make sure that you are getting this identical answer. If you are not getting this answer, then you are plugging it into your calculator incorrectly. Why don't you please pause the video, take some time to practice these types of problems using page number 4 in your compound stoich practice packet. Again, the hardest part of these is plugging it into your calculator correctly. There are 10 problems with an answer key at the bottom. Once you feel comfortable with these types of problems, please come back to the video and start it for the next and final section. The last section is going to consist of the longest types of problems, and that is going particles to grams or vice versa. I'm going to put both of those together into one section. So when going particles to grams, you're going to start with either atoms or molecules of a substance and convert to grams of that substance. If you flip it, you'll start with grams and convert to either atoms or molecules. There's 2 conversion factors that we need to use for these problems. The first is Avogadro's number, which again is 6.022 times 10 to the 23rd particles per mole. We are going to use that as a conversion factor, either right side up or upside down, depending on which of the units we're starting with. And we are going to use the molar mass of the substance. that's grams per mole, as a second conversion factor. And again, we use the periodic table to calculate that. The first problem says how many grams are in 2.34 times 10 to the 24th atoms of magnesium? So first I'm going to calculate the molar mass, right? I know Avogadro's number, it never changes, but I do need to calculate the mass, the molar mass of magnesium. So I know magnesium is Mg, and if I look on the periodic table, I find that the molar mass is 24.3 grams per mole. So I'm going to start the problem by plugging the number given to me in the question itself into the upper left-hand box. So 2.34 times 10 to the 24th atoms of magnesium will go in the first box. Now, since I have atoms of magnesium up, I need to do atoms of magnesium diagonal down. What conversion factor consists of atoms of a substance? That's Avogadro's number. So I'm going to put the 6.022 times 10 to the 23rd atoms down so that the atoms cancel out, and I know that is equal to 1 mole of magnesium. So as my atoms cancel out, I'm now in moles of magnesium, but I want to go to grams. How can I convert from moles of magnesium to grams? By using a second conversion factor known as the molar mass. Since I have moles of magnesium up, I need to do moles of magnesium diagonal down so they cancel out. I know there's 24.3 grams in 1 mole of magnesium, so I'll put the 1 mole down and the 24.3 grams up. My atoms cancel out, my moles cancel out. I'm left with grams of magnesium, which is what I wanted, so I can stop, multiply across the top, divide by the bottom to get an answer. So 2.34 times 10 to the 24th times 1 times 24.3 divided by 6.022 times 10 to the 23rd divided by 1 should get you an answer of 94.42 grams of magnesium. Please try plugging this into your calculator and making sure that you get this answer so that you know that you are using your calculator correctly. The next question asks us, how many grams are in 5.67 times 10 to the 23rd molecules of magnesium fluoride? Magnesium fluoride consists of magnesium, which is Mg with a +2 oxidation number, and fluoride is capital F with a -1. When you crisscross that, you get MgF2, and I'm going to start by calculating the molar mass of that compound. So I have 1 magnesium at 24.3 grams per mole, plus 2 atoms of fluorine at 19 grams per mole. You add those up to get a total of 62.3 grams per mole. Now I'm going to start by plugging the number in our question in the upper left-hand box. So that would be the 5.67 times 10 to the 23rd molecules of MgF2. I changed it to molecules of MgF2 because now I'm working with a compound instead of just an element. Since I have molecules up, I need to do molecules of MgF2 diagonal down. A conversion factor that I can use to convert molecules into something else is Avogadro's number. So I'm going to put the 6.022 times 10 to the 23rd molecules of magnesium fluoride down, 1 mole up. So my molecules cancel out, I'm left with moles. I want to convert moles into grams, so I'm going to use a second conversion factor, which is the molar mass. There's 62.3 grams in 1 mole of magnesium fluoride. Since I have moles up, I'm going to do moles diagonal down and then put the grams on top. Now that my molecules cancel out, my moles cancel out, and I'm left with grams of magnesium fluoride, which is what I want, I can stop, multiply across the top, and divide by the bottom. So 5.67 times 10 to the 23rd times 1 times 62.3 divided by 6.022 times 10 to the 23rd divided by 1 should get you an answer of 58.66 grams of magnesium fluoride. Please try plugging this into your calculator and make sure that you get the same answer. Let's try one more problem, but this time we're going to go backwards. So now I'm asking how many molecules are in 36.5 grams of water. So I'm going to start by calculating the molar mass of water because I will need to use it. So I know water's H2O, 2 hydrogens at 1 gram per mole each, plus 1 oxygen at 16 grams per mole gets you a total of 18 grams per mole of water. I'm going to start by plugging the number from the problem into the upper left-hand box. So that is 36.5 grams of water. Now I need to convert grams into something else in order to get to molecules. I don't have a conversion factor to go from grams of water straight to molecules, but I can go through moles to get to molecules. So the first conversion factor I'm going to use that consists of grams is going to be the molar mass. I know there's 18 grams per 1 mole of water. So since I have grams of water up, I'm going to do grams of water diagonal down, and I know there's 18 grams in 1 mole of water. Now the grams cancel out. I'm left with moles, but I need to get to molecules. So what's another conversion factor I can use to go from moles to molecules? Avogadro's number. Now since I have moles up, I need to do moles diagonal down. I know that there are 6.022 times 10 to the 23rd molecules per 1 mole of water, so I'm going to put the 1 mole diagonal down and this 6.022 up on the top. My grams are going to cancel out, my moles cancel out, and now I'm left with molecules of water, which is what I want. So I can stop, multiply across the top, and divide by the bottom. So 36.5 times 1 times 6.022 times 10 to the 23rd divided by 18 divided by 1 should get you an answer of 1.22 times 10 to the 24th molecules of H2O. Please try plugging that into your calculator. If you don't get this same answer, then you are not plugging it in correctly. That is it for this video, but before you are done, I suggest you take some time to stop and practice these types of problems using page 5 of your Compound Stoich practice packet. There is an answer key at the bottom of that page for you. And then that's it for Compound Stoich.